want to discuss about matrix, and before explaining what is matrix, let us understand what is an array, right? Let us understand what is an array. I will consider an array of integers or integer array. Of course, this concept that we'll discuss could be extended for other types of array like floating point array, character array, or any other array that we can have in programming language. An array, it is considered as a collection of homogeneous data. An array is a collection of homogeneous data. Homogeneous means the same data type. If I say this is an array, we have to give a name to the array A, and this array actually it comprises of multiple number of memory locations. Multiple memory locations. And each of the element, first of all, for users understanding, it is numbered with the help of some indexed. For example, first location is indexed at 0, second one is 1, third one is 2, 3, 4, 5, so on, so forth. This user, I mean to say from programmer's perspective. This is actually from programmer's perspective. Programmer. But however, from systems point of view or computing point of view, from systems perspective, this is identified by means of memory locations. So if this is location, address of that location is 100, then next location, contiguous location, will be 104, provided integer takes 4 bytes. Then next one will be 108, 112, 116, 118, so on, so forth. Now since it has 4 bytes, so 1, 2, 3, 4, by means 100 I mean the address of this byte. Second one, that means this 0, this location is starting at 100 and it goes up to 103. However, when I say the address of the first element, I say the address of first byte only. Similarly, when I say 112 is the address of the third element, first, second, third, actually fourth element, address of the fourth element is equals to 112. However, it goes up to 115. Apart from that, this array, since it is a collection, that is, since we are telling that this is a collection of homogeneous data, and array, basically the concept is to give a common name to the continuous memory location or contiguous memory location. The entire array is identified by the name A, and individual element, this one is known as A0. A0 is representing this location, A1 is representing this location, A5 is representing this location. Now let us say we have another, say, so this array in a programming language like C, since we are discussing about programming language C, and we are discussing array which could be implemented in C programming language. First of all, in the program, what I do, I write a statement like integer a 5. At the same time, we can also have one declaration like integer x. If it is the case, then what will happen? It is basically, it is all about the main memory that is allocated for the system or allocated for the program. Inside the allocated memory space, it will have two declarations for this. These locations are reserved continuously. 5 locations will be reserved, 1 2 3 4 5. The common name will be given as a, and first element will be identified as a0, second one will be identified as a1, third one will be identified as a3, a4 and a5. 2 is missing, 3 and 4, 5 elements. And if I, as a result of this statement, what will happen here, it will be x. But however, if you remember, whenever we give a statement like I want to give some data from the keyboard to this variable, then what I do, I write down the statement scanf, then the format specifier %d, then I write the name of x. Along with that, I also give this one ampersand. This ampersand is called the address operator. Address operator. What does this mean? We ask the compiler, because the compiler do not know about x or y. He is aware only about the address, let us say 1000. Since it is an integer, so that's why 1000, 1001, 1002 and 1003. These 4 bytes will be allocated for x. Nobody else can take that location. Now, since I am telling scanf %d ampersand of x, what the compiler will do, compiler will go to address of x. Here the address of x is 1000. And in the location 1000, this computer will put the number, whatever been typed from the keyboard. Suppose the 70 is stored here. So it means that 70 will be stored in the location of x. This is the identifier for the programmer, and this is the identifier for the system. Similarly, here also, whenever I want to access this one, let us assume that we are starting from 100, 104, 108, so on so forth. What we will do, we can do the same thing here, like I want to put any data in a specific location, say here. I will write the statement like scanf %d ampersand of a of 4, because a of 3. I know that the identifier for the programmer for this location is a3, and the address, this ampersand, this address will be extracted by the computer by its own, and that will be nothing but 112. So it will put the data, whatever I type. Let us suppose that I typed 40. That 40 will be typed in this location. This is the way that it follows in the compiler. Okay, so this continuous memory location, one more thing, if this is a group, individual elements could be extracted or could be scanned by the programmer using the index, any index 1 2 3 4 within the limit. And also we can use a loop in order to access those, let us say this I, and we can generalize it like ampersand of a of I, and where I will vary from 1 0 to 5 0 to 4, right? So if it is this, if it happens in this way, what we can do, we can extract or we can scan the element as a single individual element. There is no harm in it. However, our objective is not to access the individual elements. That's why we have given a name to this array. So if I say A, that means A actually the name of the array. A is equals to the name of the array, name of the array, right? And A itself is equivalent to the ampersand of A0. When we'll be using, or we will talk about the address of the array, actually it means the address of the first byte of the array. So in this case, A is equals to ampersand of A of 0, which is equals to 100. This is very, very important thing to be remembered. Now this address, whatever I say, this address we can manipulate. We can make use of the address of the array, or we can make use of the address of the first byte of the array in order to manipulate the content of the array. So it derives us to another concept which is called a pointer, and this pointer can be used to extract element from the array. However, in this session we will not talk about pointer. That's why let me stop this topic here in regarding accessing elements from the array using pointers. Suppose that our main purpose is to discuss matrix. Actually this matrix is nothing but two-dimensional or multi-dimensional array. For time being, let us assume that this is two-dimensional array. Consider one declaration in your program like integer a 5, and take another declaration integer b 5, let it be of same size, integer c also 5, like this. If these are the declaration statements, that what it can do, what the compiler will do, for a it will reserve 5 different locations and it will be named as a, and all the individual elements could be retrieved using A0, A1, A2, A3 and A4, like this. For B also same thing will happen. And this one will be B0, this one will be B1, this one will be B2, B3 and B4, and common name will be B. So also in case of C will be 0, 1, 2, 0, 1, 2, 3 and 4. If you remember, then all the arrays are defined as integer, so they will take 4 bytes. If it is 1000, accordingly other addresses will be assigned to the first byte, and that can be used for accessing the elements. If it is say 4000, then accordingly all others 4 plus 4 plus 4, it will give the next location. If it is a 6000, then also here the same thing will happen. Now these are multiple arrays, 3 different arrays that we are declaring to store some similar data, integer. So this is clear that the first address, this a is equals to a of 0 as far as the address is concerned. Similarly, b, address of b is equals to address of the first element of b as far as address is concerned. Similarly, c also has the same meaning, because, and that follows the address of the first byte is the address of the common name array. Address of the first byte 4000 will be the address here. Here it is 1000. It will be 4000. It will be 6000. Only difference is they are scattered over the main memory. But since this is of the same type, and all are of the same range, 5 elements, 5 elements, 5 elements, so C has designed another method of declaring such kind of array declaration. In this case, what we can do, instead of giving 3 different names, what we can give a common names. Let us suppose that X is the common name given to all these 3. And what I will do, I will tell how many arrays, individual arrays, 3. So I will put the first one 3. How many elements in their range? This range is say 5, like this. This declaration is equivalent to this declaration, where X represents, X is equals to A plus B plus C. If this is the case, data type will be same, because data type is same for all. This can be replaced as integer X, 3 and 5. If this is the case, then what it will do, what the compiler will do, it will reserve certain spaces like this, and 1, 2, 3, 4 and 5. So this 5 means 1, 2, 3, 4, 5, like this. And this is also 0, 1, 2, 1, 2, 3. That means this 3 indicates this one. Now the name of this common name is X, and this one is also known as X0. This one is known as X1. This one is known as X2. So if we compare this declaration with this declaration, then A is equivalent to X0. B is equivalent to X1. And C is equivalent to X2. So it becomes a matrix in our mathematical language, but however, this is called a two-dimensional 2D array of integers. 2D because there are 2 dimensions. One is the number of rows, and second dimension is columns. The number of rows equals to 3, number of columns equals to 5 here. So it means that it creates a matrix of 3 by 5, 3 rows, 5 columns. And this is the concept used in C programming language, and we call it a two-dimensional array. And individual elements, suppose that I want to access an individual element, this element I want to retrieve. What I need to do, first of all, I have to take the common name X. Then I have to have 2 dimensions. I have to specify which row. Here this is in the second row. Second row means always -1. This is 1. And then I have to take the column 1, 2, 3, 4. 4 means 4 minus 1, which is equals to 3. So this is equals to this location. If I want to put something in that location, then I can tell, let us suppose that I want to extract the element from here. What I can do, I can tell ampersand of X1, 3. That will perfectly fetch the content, or it will perfectly mean this element. Matrix, sparse matrix. Since it is a matrix, that is why we can say sparse. Let us keep this sparse 2D array. If we come to the declaration of such 2D array, then I will definitely have one declaration integer. Let us say M stands for matrix, and let us assume that it has 2 rows and 3 columns, for example. And if it is so, then we will have 2 rows like this, 2 rows, 3 columns, 1, 2 and 3. Okay, 1, 2 and 3. Let me remove it. This is the array, and the name given to this array is M, and the elements, various elements in the array are, this is called M0, this is M0, this is M1, this is M1. That means there are 2 single dimensional arrays. There are 2 single dimensional arrays. For the time being, let us substitute this A, M0 as A, M1 as B. This is, for time being, assume that this is equivalent to A, this is equivalent to B. Now if I go this direction, this is 0, this is 1, this is 2. If I say this element, actually this is A2, this is A2. If I say A2, and what is A? A is M0. If I replace A with M02, that means this element is identified as M02. M02, because if you go from here, this is 0, this is 1, 0, 1, 2, this one exactly. If I want to find this element, then first of all, this is B, and B, this is 2, and B, replace it by M1. I will write M1, and this is 2, right? 1, 2, 1, 2. This is 1, 2. Am I correct? So this is nothing but M12. So individual element could be extracted using their various indexes. Now, what is a sparse matrix? If a matrix contains more than 50% zeros as content, then that matrix is called a sparse matrix. Since it is M is a 2 by 3 matrix, so it has 6 elements. 50% of 6 is 3. If we have more than 3, say 4 zeros, that means this matrix, it has 0, it has 0, it has 0, it has 0, it has 5, it has 6. So out of 6 elements, 1, 2, 3, 4, 5, 6, out of 6 elements, 4 zeros and 2 non-zero elements. So it's a sparse matrix. But however, if I have this matrix as 1, 2, 3 rows, 2 rows, 3 columns, say this is 2, this is 2, this is 1, this is 0, this is 0, this is 2, this is 3. So only 2 elements are 0, rest of the elements are non-zero. That's why in that case M is not a sparse matrix, not a sparse matrix, not a sparse matrix. So what is the problem with the sparse matrix? Actually no problem. There is no problem with the sparse matrix. But always what we do when we write a big program, very big program, and suppose that your matrix size is not 2 by 3, it is say 1000 by 1000. If it is 1000 by 1000, then total number of elements will be 6 zeros. These many number of elements. And if this many number of elements, integer of the type integer, that means multiplied by 4, which is equals to 40 lakhs. 40 lakhs bytes. 40 lakhs bytes means, if you say 40 lakhs base, that is 4000 KB. 4000 KB data. But however, 50% of this one, which is 20 lakhs, 20 lakhs bytes, are all zeros. It is believed that if it is the case, then we are 50%, we are wasting 50% of time, 50% of the total space occupied by the matrix. That is why we need to do something different, so that instead of storing all the 10,000, not 10,000, how much? Instead of storing all the 10 lakhs of elements, 10 lakhs of elements, because out of 10 lakhs, 5 lakhs are zeros, we will store only 5 lakhs of data. If it is so, then 50% of the, at least 50% of the space will be saved. But this is not only the case. In case of sparse matrix, maybe the size is this many bytes, means the 10 lakhs byte size. Out of 10 lakhs bytes, only 5 elements are there in the entire matrix. That can also happen. That is also a sparse matrix. Depending upon the problem that we solve, it may happen. If it happens, then we need to find a solution in order to store the matrix in a compact way. In the compact way does not mean that we will lose any data. It means that only we will store the data in a compact form without losing any data or without losing the identity. So in that case, what I need to do, I need to store here, in this case, I need to store only 5 and 6. But while storing, I should keep track that 5, the location of 5 is 0, 2, and location of 6 is 1, 2, right? And this is a compact form representation. However, when we will give the information to the end user, that should exactly come as this matrix. We cannot simply tell the end user that take 0, 2, 5, take it, 0, 1, 2, take it. It's not that. We have to represent. This is called representation of the data, which is nothing but information. Your information should be in this form. Only while storing we will use the compact form, but however, while it is displaying, we will give it in a perfectly acceptable or understandable form. So if it is supposed to be done, then we need to do something very special which will be used to represent a sparse matrix, right? So that is called, first of all, while I am talking about a program of sparse matrix, there are two things comes into picture. One is, first of all, the user will give you the matrix. Matrix means you will store it in 2D array. Then you have to test, is the matrix a sparse one? If it is a sparse, then next step will be to represent it, representation of sparse matrix in a compact form. So while representing the sparse matrix into compact form, there are two methods. One is called the representation of the sparse matrix in the form of another matrix or another 2D array. And second method is representing the sparse matrix in the form of a linked list. We will not go into the linked list representation in this session. We will go only to the representation of the sparse matrix in the form of another matrix in this session. Recapitulate basically all the things that I have told you. First of all, sometimes it happens that the elements in the array are not all non-zero. Maybe 50% or more than 50% elements of the matrix are zero. If this is the case, then it becomes a sparse matrix. And storing the sparse matrix as it is wastes it wastes lot of space. In order to minimize the space wastage in storing the sparse matrix, there are different methods. One method is representation of the sparse matrix in a two-dimensional array. However, what we will do, we will create a new matrix, new compact matrix. This compact matrix will always have 3 rows. Number of rows are fixed. Rows will be equals to 3, 0, 1 and 2. However, number of columns will be equals to number of non-zero elements. If there are 4 non-zero elements, then there will be 4, 2, 3, say 5, say 4. That many number of columns, right? So this is the compact representation of the 10 by 10. Say this matrix was 10 by 10. That means 100. However, there are only 5 non-zero elements. That's why I have represented this matrix in the form of a different compact matrix, where the number of rows will always be equals to 3 and number of columns will be equals to the number of non-zero elements. Since the number of non-zero elements equals to 5 here, I have given 5 different rows, I mean columns, not rows. I have created that one as this. So I will give the name of new one as compact matrix, say, which will be having 3 rows and 5 columns. But before that, we have to decide what is the value of 5. That can be done by checking the non-zero elements, number of non-zero elements in the matrix. So if this is the case, what I will do, suppose that this element represents a row number 2 and column number 4, 2, 4 has some value 17. What I will do in this one, the first element, I'll go this way. This is the first element. I'll put 2 here, 4 here, and the element 17 here. Again, suppose somewhere here we have another non-zero element 10. This maybe is equals to number of rows is 3, 2, for example. So I'll put 3 here, 2 here, and I'll put the element 10 here. That way I'll go. And this is how many elements it will be there? 3 multiplied by 5, which is only 15. 15 multiplied by 4, this one is having only 20 bytes. However, this one having 100 multiplied by 4, which is equals to 400 bytes. So a huge space is been saved by representing the sparse matrix in a compact form. So this is the problem statement. Write a program to read a square matrix of order 4. Also perform a test to check if the entered matrix is a sparse matrix or not. If the matrix is sparse matrix, then write a function to represent the given sparse matrix in a multi-dimensional array, right? I told you that there are 2 methods to representing a sparse matrix in a compact form. One is to use another multi-dimensional or 2-dimensional matrix, and one method is to use a linked list. Here we will see how to use 2-dimensional array in order to represent the sparse matrix in a compact form. First, this is the main program. This main program, there is one matrix defined. Name of the matrix I have given as integer matrix 10 by 10. I'm considering 10 by 10 matrix. However, I'm reading only 4 elements in a row and 4 rows and 4 columns, 4 by 4. If it is 4 by 4, altogether it becomes 16 elements. And from the 16 elements, once the matrix is formed, then here the following section counts the non-zero elements. What I am doing, this portion is the count of non-zero elements in the given matrix. Then after that, here, just below this, I am, first of all, I am checking whether the matrix is sparse or not. If it is a sparse matrix, that means I am counting the number of non-zero elements. If number of non-zero element is less than equal to 8, I am considering equal to 8 is also as a sparse matrix, but you can take less than 8 as well. And then here in this one, I am representing the sparse matrix into a compact form. Number of rows is 3 and number of elements, I mean number of columns in the matrix is equals to count non-zero elements. Yes, and non-zero elements, count non-zero elements, and count non-zero elements are coming from the checking process, this one. Then what I am doing, I am scanning the matrix whichever given by the user that was stored in integer matrix. Then I am putting only the element which is non-zero. If it is non-zero, then I am putting it here. Putting where, what I am doing here, the location I of the original matrix, J of the original matrix, then the value entered by the user in that matrix. So this is the program. And finally, what I am doing here, I'm also showing the content of the sparse compact matrix. Here I'm showing the content of the sparse matrix. Here I'm showing the content of the compact matrix. This is the simple program. Execute this program. And so here actually I have to enter 16 elements. 16 elements separated by a space. This statement is very clear. You can enter 16 elements. But what I want to do, let me not do this way. First of all, let me compile this program. Name of the program is Sparse Matrix, Sparse Matrix check .c, then say sparse .out. Let us suppose that is the name of the program. Apart from that, let me create a file from where I will take the input. Hopefully you know these steps, how to do this. Let me write cat. I'll put the output to a file data.txt, then press enter. 16 elements I want to, 1, say first 0 0 0 1 0 0 0 4 0 0 0 2 4 8 what 3 4 more 0 0 4 5. Okay, so let me press Ctrl Z and let me check ls minus l data.txt. This file is there. Minus, this is 32 bytes. Okay, this is this data comprises of 32 bytes. Now clear the screen, then let me execute this program dot sparse dot out, and the data will come from the data.txt. Okay, so press enter. 16 elements are there, then it will take the data, it will put it here in the, press enter. Okay, see, this is the sparse matrix. Let me make it bigger for you. So the given matrix is a sparse matrix with 5 non-zero elements. These 1 2 3 4 and 5. These 5 elements are non-zero elements, and elements are 0 3, the value is 1, 0 3, this is 0, the first row is 0, and 0 1 2 3, right? 0 3 is 1, 1 3 is 4, 2 3 is 2, these elements, and 3 2 is 4, this element, and 3 3 is 5 this element, right?